looks at its routing table and says, okay, to get to 10.1.1.0, I send it to 192.168.1.2, right? The other thing it could say is, to get to 10.1.1.0, I send it out S0. So you can either use the name of the local interface or the address of the next hop interface. Cisco now considers it preferable to use the address of the next hop interface, but both will work, and you'll see them both show up. Okay? Not quite oh my stars, what have I gotten myself into? All right. So a path is nothing more than one router's knowledge of how to get a message to a remote network. And they are incremental. In other words, this router's function is not to get the message to there. This router's function is to get it to there and let this router decide where to go next. A message is rerouted at every router it hits. Okay? Even if you're running a fairly intelligent protocol like OSPF, and this is calculated the full path metric, it still only switches it to the next router, and the next router goes through the same thing all over again. They maintain independent routing tables, independent metrics, they make independent decisions. Okay? So what this router's job is to find out if the address is in its routing table. If so, do I have, in this case, they use, see the local interface name. Do I have a path to send it there? And you'll notice that in this case, to get to either network, same resolution. Nothing illegal about that. You don't have to have a separate interface or a separate next hop address for every network you're going to. You may have a dozen or two networks resolving to the same path because that's how you get, and it branches farther down the line than that. Okay? Shorthand. 10.0.0.0/24 is subnetted, and I'm currently aware of two of the possible subnets. Okay? So it can differentiate from 10 dot anything to the third octet from each other. I'm currently aware of 10.1.1.1 and 10.1.1.2. I learned about them via the RIP routing protocol. So we used a very simple protocol. I'm also aware of 192.168.2, which is the connecting network, and I learned about it because it's directly connected. Okay? Somebody programmed this knowledge into me. This is a administrative value, administrative cost. For RIP, it's a standard 120. Say you have a choice of two different routing protocols. RIP, which is 120, and OSPF, which is 90. It will prefer the OSPF route because it's theoretically better. Okay? Followed by a metric that says how far away it is. RIP uses hop counts. So what it's saying is this is one hop away. That interface to that interface is one hop. Okay? I'm going to go via the next hop address, 192.168.2.2. This is how long ago I refreshed this knowledge. So this knowledge was good 8 seconds ago. And I'm going to use this local interface, fast Ethernet 00. Not so tough, right? Get used to reading them, they're not bad at all. Can I have more than one path to a single network? Sure. In a lot of cases, it's preferable to have multiple paths. You can load share, you can do fault recovery, you can do all kinds of things with multiple paths. Okay, so just like you can have multiple networks mapping to the same path, you can have multiple paths going to a single network.
How will the administrator know how many hops it is to the next router?
It doesn't have to, the routers do. In this scenario, when this router told this router where that was, it would tell it it was 0 hops. When this wrote it into its tables, he would say, well, if it was 0 from him, I'm going to add 1 and it's 1 hop from me. So the word comes over here that it's a 1 hop destination, and this one marks it as 2. It increments it every step when it learns it on a routing table update. At that point, no administrative work required.
So in actual, sir, hop will be like a router?
A hop is a router-to-router interface. Gee, we just did this. Remember I told you, when you get into routers, you're going to get really happy with the command line? Because Cisco doesn't write a GUI for routers. There is one for switches, but not for routers. 80-20 rule applies. Cisco IOS probably has 450 commands in it. You'll use about 25 of them a lot. Route is one of the ones you'll use a lot, both at the PC level and at the Cisco router level. Okay. Another one you can use to find out about things is, remember our buddy NetStat? What did NetStat do?
Give you stats on the network.
Like what?
Like your,
Told you about all
Yeah.
all open TCP ports, right?
right. Yeah.
TCP IP ports. By the way, whenever you're at the command line at like a Windows box and you want to go to the command you had before, just hit the up arrow. Makes it way easier rather than retyping, especially when you type the way I do.
So, do what?
Up arrow will take you to the previous command.
Okay.
And now I'm going to show all the switches that can be put behind NetStat. Okay? These will all get it to do different things. -R will show you the local routing table. Okay? So right now, everybody see that, or is it down too low? Is that better? This will show you all of the routing information known to my computer. Okay? And it will show you what networks it's capable of finding and how it's going to get there and what gateways it's going to use. That's a fun one to play with.
So what's 192.168.202.82?
This is another host though, isn't it?
Is that your local IP address?
By golly, that's me.
That's just another host on the network, isn't it?
That's my host, as a matter of
Well,
fact.
because it's a loopback, so yeah.
It goes to the loopback gateway because that's what I'm going to do to test my own
And you
address.
get 255 because it's broadcast for
That's
you.
broadcast, right? Okay, and the loopback interface. And the rest mapped to my localized interface. By the way, when you ping, the rule is ping the loopback address, then ping the local address, then ping another address on your subnet, then ping a remote address. If you ping a remote address and it works, the first 3 by default had to have worked. So if you want a quick check, ping a remote address. If it fails, start checking. When I ping the loopback address, what does it test? Test the protocol stack, does not test the network card. When you ping your own your own address, that tests your network card and network interface. So the first is a software test. The second tests your interface. The third